Okay, so dear student, in this class we discuss about a very important law, that is Ohm's law, and from this law we get a relationship between potential difference and electric current. In previous class we discussed about the electric potential difference, and we also conclude that the battery or cell which maintain the potential difference, and without battery or cell potential difference does not exist. And when potential difference generated or created or produced, after that we get the electric current, otherwise not. So there is one relationship between that potential difference and a electric current, and from this law we get that relationship, and this is discovered by scientist Ohm. That's why this law is called Ohm's law. So let's see what is this statement. It states that potential difference between two ends of a conductor. We know that we always measure the potential difference across the two ends of a conductor. That's why we connect a voltmeter parallelly. So potential difference between two ends of a conductor is directly proportional to the current passing through it. That means if potential difference increases, electric current also increases. If it will decreases, electric current also decreases. And there is some condition. The condition is temperature and other physical, that means pressure, other physical conditions remain constant. So if you don't write this provided temperature and other physical conditions remains constant, then this statement is incomplete. So when you write down this statement, the whole thing you can write. So once again, the statement, it states that potential difference between two ends of a conductor is directly proportional to the current passing through it, provided temperature and other physical conditions remains constant. Okay, so we know that potential difference is denoted by V or delta V. So now here we consider only V. Okay. And electric current is denoted by capital I. So from this statement we can write V proportional to, this is the proportional sign, V proportional to I. Now when we write a equal sign, we must multiply with a constant term. So here the constant term is R. This R is called resistance of a conductor. So here we get another one new term of this chapter, that is resistance. What do you mean by resistance? Resistance means resist the flow of charge. Resist means opposes the flow of electric charge. Okay. So from the equation V equals to Ri, from here R stands for resistance, and resistance means resistance of a conductor. This is a property of a conductor. Each and every conductor has a resistance. Some conductor has a maximum resistance, some conductor has less amount of resistance, but it has a resistance. Okay, so resistance of a conductor, it is a property of a conductor. What happens in this in this property? That this resists or this opposes the flow of electricity or flow of electric charge through it. Okay. Now one thing, if you write here, we write V proportional to I, so V equals to R into I. Now if we write I proportional to V, then if you write this one in mathematical form of Ohm's law, if you write like this way, I proportional to V, then I equals to, you can write V by R. Okay, so here the proportionality constant is 1 by R, not R, and 1 by R is called conductance, not the resistance. Okay, 1 by R, the reciprocal of resistance is called conductance. Okay, so any one mathematical expression you can write, but remember this one. If you write V proportional to I, so V equals to R into I. If you write I proportional to V, then I equals to V by R. Here proportionality constant is 1 by R, and this 1 by R is called conductance. Okay, so we get from this Ohm's law, we get another one new term that is called resistance. Resistance means resist the flow of charge. It is a hindrance property of the conductor. Okay, and every conductor has a resistance. So from this equation we can write R equals to V by I, potential difference by electric current, and the resistance is, symbol of resistance is this. When we draw the circuit diagram, in the place of resistance, if we use any resistance, then we use this symbol. This is a symbol of resistance. Now from this expression we get the unit of resistance. What is the unit of potential difference? We know that that is volt. And what is the unit of electric current? That is ampere. So volt per ampere is the SI unit or unit of resistance. In one word, or because scientist Ohm this law discovered, that's why in one word, volt per ampere, it's called Ohm, and it is noted by like this way. Okay, it is called Ohm. So when we solve any numerical, in that time when we write the unit of resistance, we use this symbol. This symbol means Ohm. Ohm means it is represent the resistance. So from this expression we can write 1 ohm equals to 1 volt by 1 ampere. So why we consider 1? Because now we define 1 ohm. In a previous chapter we also, when we define 1 ampere, 1 volt, that time also we consider 1 that in that expression. So now we define 1 ohm, that's why we consider resistance of 1 ohm, potential difference also be 1 volt, and current is 1 ampere. Now let's see how we define 1 ohm. The resistance of a conductor is said to be 1 ohm if a potential difference of 1 volt across the ends of a conductor makes a current of 1 ampere to flow through it. That means suppose this is a conductor, conducting wire. Okay. If the in that two ends, if the potential difference is 1 volt and due to this potential difference the current flowing through it's 1 ampere, then we say that the resistance of this conductor is 1 ohm. Okay, so this is the definition of 1 ohm. Now we represent this. This is a very important topic in this chapter, and many questions will come from this chapter. 1 marks, 5 marks. Now the graphical representation. Before that, this diagram is also in the present in the NCERT book. Okay, what is this diagram? From this diagram we get the graphical representation of this expression. Okay, so in that diagram we used many cells. Here I consider 1, 2, 3, 4 cells are there. One resistance, that means one any conducting wire has resistance R. So we measure the potential difference across these 2 points. That's why we connect voltmeter parallelly, and we measure how much amount of current flowing through this circuit. That's why in series we measure ammeter. We connect ammeter, and here this is a switch. It is denoted by K. Okay, this is a closed circuit, that's why we use dot sign. So the current, we know that direction of current positive to negative. Now here we consider, see here some dotted line also be present. It means first of all we connect this end of a wire here. That means in this circuit these cells are not present. Okay, only one cell is there. Okay, so from this one cells we get some amount of current, and we get also a potential difference. So we consider when we connect number of cells is 1. In a ammeter we get 1 ampere current. In voltmeter we see that is 1 volt. Okay. Now we connect another one cell with this first one. That means these two are absent. Now this circuit contains 2 cells. Okay. So now from this one, number of cells is 2. We get the amount of electric current passing through this circuit is 2 ampere. And the potential difference is 2. And okay. Now we connect third number. So here we get third number cells. So 3 ampere, 3 volt. And now at last we consider, because here I consider 4 cells. So last one, when we consider the last one, so this circuit contains 4 cells. So 4, in ammeter we get 4 ampere current. In voltmeter we get 4 volt of potential difference across the R. Okay, so from this experiment, we conclude that as we increase the number of cells, the amount of electric current also increases and the potential difference across any resistance is also increases. So main is this source. Okay, this is called source. Without this, we can't get any electric current or any potential difference. Now, from this expression, as we know that V equals to Ri, R equals to V by I. So, if we can determine the value of R, V by I, so we get for 4 observation, we get same resistance, 1 ohm, 1 ohm, 1 ohm, 1 ohm. Okay, so as the current and potential difference also increases, but its resistance of this conducting wire also constant, 1, 1, 1, 1. Okay. Now, if we plot the graph with these two data, V versus I graph, we consider this is 1, this is also 1. So, when current is 1, voltage also 1. This is 1. Okay. Now, current is 2 ampere, voltage also 2 volt. When current is 3 ampere, voltage also 3 volt. And when current is 4 ampere, voltage also 4 volt. Now, if we join these 4 points, we get a straight line which is passing through the origin. So, the nature of the graph is straight line. Okay, when we plot a graph in case of a Ohm's law, V versus I graph, the nature of the graph is straight line which is passing through the origin. Okay, so this is a practical example and this all data we consider. Okay, now when we do this practical, this Ohm's law, this practical also included in your syllabus. Okay, so when we do the practical in practical class, we understand more. Okay, now in practical class we use only one source. Okay, but we need to different amount of current and different amount of potential difference. So how we can get that with a device we use in that time which regulate the current, and that device is called rheostat. That device is called rheostat. Rheostat means variable resistance. As we varied that one, so we get different potential difference and different current also. So in practical class we use this device rheostat. It looks like this way. One jockey is over there, one coil is wrapped over this body. Okay, this is a coil of wire. Here we get 2 points. These 2 are A and C is a fixed point. And this is from this current in and this one is a current out. And B point is a variable point. And B point is connected with a jockey and this jockey is slided over this coil. Okay, as it slided over, suppose in this position, the current in from this side, current goes from this side, then from here it will out. So in this wires, no current is present at that time. Now if we move jockey here to here, that means one extra wire is included. After that, the current flowing through this side. So like this way we can vary it, or we can control the current and the potential difference. So that device is called rheostat. Rheostat means variable resistance. So now let's see what is a practical diagram, or which diagram we use when we doing this practical with the rheostat. So this is a practical diagram, circuit diagram for Ohm's law. This is a battery or cell. Battery means one or more cells when connected together. This is ammeter. We know that ammeter connected in series. This is a resistance or the conducting wire whose resistance we find out. And we know that we connected voltmeter parallelly. And this is a rheostat. Okay, so in that diagram we get two fixed point. A and C is a fixed point, B is a variable point. So in this diagram, how we can understand? So this rheostat, this is 1 point, this is 1 point. This 2 point is A and C. So this 2 is a fixed point, and this point is a B point. This is a variable point. That means here the jockey is connected, and as we move jockey from one end to another end, it will vary, and we get the different potential difference across the resistance and different amount of current also. So this is the practical diagram. This is a very important diagram, and this diagram we used when we taking the data in practical class from voltmeter and ammeter, and we also draw the graph V versus I. Okay, is it clear? Thank you.